The problems that we just solved in the past several examples that you looked at, if you sort of think about how you did that. So you had the beam and the load, and you cut sections at the different points. This is the classical approach of drawing bending moment diagrams and shear force diagrams, or it is also known as the method of sections. And it is quite intuitive if you think about it. So if when you had the beam, you had the loads at different parts of the beam, you took the sections, and after that you wrote the equations for the shear force and the bending moment for the different sections. Then you went from establishing the equilibrium from left to right or right to left, whichever was convenient, and eventually from those equations that you derived, you drew the shear force diagram and bending moment diagram. Now, while this method is extremely intuitive because you can see and you know what you are doing, sometimes it can be very tedious. For example, suppose I give you a beam. Let's just go ahead and draw a beam. So suppose I give you a beam with maybe some boundary conditions. So let's say this beam has a pin at one end and say a roller at the other end, and the beam say is subjected to a variety of loading. For example, so let's say the beam has a point load, has a uniformly distributed load, it has another point load, another point load. Here at this point maybe it has a couple over here. I can go ahead and maybe put another point load acting something like this over here, right? Maybe at the very end I have a little bit of a triangular load which is acting, and so on and so forth. I can go and make this problem as complicated as I can. Now for this problem, if you think of doing this using the traditional method of sections, where all would you have to take the sections in this case? You have to take the sections. You'll probably have to take one section here, another one just after this load ends, one over here, one right after this load, one in between this uniformly distributed load, one right after that here, one here, and maybe at the very end right after that moment x. So let's just do a count. I have 1 2 3 4 5 6 7 8, right? So total, to draw the bending moment and the shear force diagrams for a problem like this, you actually need to sit and write the equations of equilibrium for these 8 different sections, and that tells you how tedious this process becomes. Now, your saving grace for solving problems, these kinds of problems where you may have a more complicated type of loading than the one we saw, and which would require you to ideally find the bending moment and the shear forces at all these points of discontinuities in between the loads, within the loads, and so on. We are going to use a very efficient technique which is derived from the relationship between the load, the shear force, and the bending moment, right? Once we understand those relationships, you will see that how easy it becomes to draw shear force diagrams and bending moment. So let's go ahead and take a look what are the relationships between the load, the shear force, and the bending moment.